Hi students, welcome back. So in this part we'll be discussing about the properties of your inner transition elements. So let's start with this part. Next, properties of inner transition elements. So magnetic properties. So first let's discuss about the magnetic properties of the lanthanides. So the lanthanide ions other than F0 type, just like La3 plus and Ce3 plus, and the F14 type, Yb2 plus and Lu3 plus, all are paramagnetic in nature. So this paramagnetism, it rises to the maximum in neodymium. So this is the first important property of magnetic properties. Next important thing is that the lanthanides have very high magnetic susceptibilities. Why? Because of large number of unpaired f electrons. So larger is the number of f electrons, the two unpaired f electrons, you have higher magnetic susceptibilities. Oxidation states. So predominantly they show +3 oxidation state. So the +3 oxidation state in La, Gd, Lu are especially stable. Why? Because they have empty filled and completely filled FSubshell respectively. But your Ce and Tb, they show +4 oxidation too. That is Ce4 plus. So when you have Ce4 plus, you have 4F0, and Tb4 plus, you have 4F7. Occasionally +2 and +4 ions in solutions or in solid compounds are also obtained. So this irregularity rises mainly from extra stability of the empty half filled or fully filled FSubshell. So this is apparent from that. It is apparent now that so this irregularity is only because of this extra stability of your empty half filled and fully filled FSubshell. Next, the main stable oxidation of lanthanides is +3. So hence the ions, for example, if you have +2 oxidation state, it tends to change to +3 oxidation state by loss of electron, and it acts as a reducing agent. But whereas +4 oxidation state, they tend to change to +3 oxidation state by how? You have to gain electron, right? So by gain of electron and act as a good oxidizing agent in aqueous solution. So now at this point of time, it is very important to think this point, why Sm2 plus and Eu2 plus and Yb2 plus ions in solutions are good reducing agents, but in aqueous solution of Ce4 plus it's a good oxidizing agent. What do you think is the answer? The answer lies in this first important point, right? Next, properties. So what are the properties of lanthanides? So lanthanides are silvery whites of metals. They tarnish in air rapidly. Their hardness increases with increase in atomic number, right? You can see that samarium is very hard and it is as hard as steel hard. Next important thing is that they are good conductors of heat and electricity, and there are also radioactive elements like promethium. So inner transition elements are also known for their radioactivity. Chemical properties. So the metals combine with hydrogen when reacted or when gently heated in the gas. So this results in the formation of carbides Ln3C, Ln2C, Ln2C3 and Lnc2. They are formed when metals are heated with carbon. But they liberate hydrogen from dilute acids and they burn in halogens to form halides. And also very important thing is that they form oxides and hydroxides, M2O3 and MOH thrice. So they are basic like alkaline earth metal oxides and hydroxides. So they form basic hydroxides or basic oxides like your alkaline earth metal oxides and hydroxides. So in a nutshell, this picture gives you an idea. This animation gives you an idea about the chemical properties of lanthanum. So lanthanum, when reacts with acid, you will get hydrogen. With halogens, you will get LnX3. With H2O, you will get LnOH thrice and hydrogen gas. When heated with carbon at high temperature, you will get Lnc2. When heated with nitrogen, you will get Ln. When heated with sulfur, you will get Ln2S3. But when burned with oxygen, you will get oxide of lanthanum or lanthanide. So it's a lanthanide oxide Ln2O3. Next, actinides. So once we have finished lanthanides, we next have actinides. So all isotope of actinides are radioactive, right, with only thorium 232, uranium 235, uranium 238 and polonium 244. They all have half-lives, but only thorium and uranium, they occur naturally. And very important thing is that they are more abundant in Earth's crust than tin. So the others must be made by nuclear process. So what are nuclear process? Nuclear process are artificial process. Nuclear process are artificial process. So actinides oxidation state is +3. They also exhibit an oxidation state of +4. But there are certain actinides such as uranium, neptunium and plutonium which exhibit the oxidation state of +6. So next important thing is that the actinides show actinide contraction. Just like lanthanide contraction, you have actinide contraction, and in actinide contraction again what is happening is that the pure shielding effect or the poor shielding effect, it's a pure poor shielding effect of the nuclear charge of 5f electrons. So all the actinides are radioactive. Actinides are radioactive in nature. Actinide contraction, obviously just like lanthanide contraction, because of effective nuclear charge, because of poor screening nature of your f orbitals, so decrease in atomic radii takes place. So the same thing happens, the size of atoms N3 plus ions decreases regularly along actinide series. The steady decrease in ionic or atomic radii with increase in atomic number is called actinide contraction. So the contraction is greater from element to element in the series. It is due to the poor shielding effect by the 5f electron. Magnetic properties. So actinides are paramagnetic in nature, they have paramagnetic behavior. The magnetic properties are more complex than those of lanthanides, obviously, right, because they are present in the last period. So the melting and boiling point, they have high melting point and they do not follow regular gradation or regular trend of melting point or boiling point with increase in atomic number. So students, we have discussed about the properties like magnetic properties of your lanthanides as well as actinides. So in our next part, I will be discussing about the previous JEE questions from this topic of transition or inner transition elements. So till then, just take care of yourself, stay tuned to your sessions. Goodbye, take care.